Here is my 5th DER of my grade 12 year and last of my ACES career, Project 3.5, task without an interesting name, or to which I will be referring to as Twain. Within the Project Twain, we were tasked with using our new understanding of assembly-level coding to create a project on our Dolgan Development Board V7 to manipulate the position of a single LED on the Moreland bar graph through the use of an analog input device, in this case a 10K ohm potentiometer. This project is truly built out of only one domain, software, but can be broken down into 3 main components: the ADC setup, shift out, and loop. First is ADC setup, in which I'm sure you can guess the ADC is set up, preparing for a low-level analog read. Firstly, a 0 is loaded into util, followed by using util to load a 0 into the ADMUX, essentially guiding the ADMUX as to which pin it will be reading, in this case A0, similar to a high-level pin mode 0 input on Arduino in C++. Next, the ADC is enabled to start a read. Once complete, the ADC generates a 10-bit result, presented in the ADC data registers, ADC high and ADC low. The result is shown right adjusted by default, but can optionally be presented left adjusted by setting the ADLAR bit in ADC SRB. If the result is left adjusted and no more than an 8-bit precision is required, similar to in this project, it is sufficient to read the ADC high, which is then inserted into R17, or referred to as ADC read in this project. Secondly is shift out, where the value stored within the register util is shifted onto the Moreland bar graph. For starters, similar to when using any shift register, the latch is first set low, followed by an 8 being loaded into the register named count, as bits must be shifted 8 times. The following is then repeated as the count is decreased until equal to 0. First, the clock is pulled low, then a sequence used for efficiency in which the bit to be shifted onto the bar graph is assumed to be low, setting data low. Next, the called bit within the register util is checked to see if it is low. If so, the code was initially correct to have made data low, and the next instruction will be skipped. If not, meaning the 7th bit was high, data pin is then set high. Finally, the bit right of that shifted out is positioned into the 7th bit, and the count is decreased, waiting until the count is equal to 0. Thirdly is where everything is pulled together, as loop is called upon. Within loop, firstly is ADC setup, called, and ADC read is moved into util, the value that is read from the pot. Next, util is shifted logically right 5 times, converting util into a value between 1 and 7. Furthermore, a new register val is loaded, with a 1 shifted left the util value, creating a binary value. This value is then decreased by 1, making trailing bars to be moved back into util, and then shift out is called. Finally, loop is reset, repeating the function with the new ADC read.